Resistivity. Electricity 8 is on resistivity. Okay, here's a piece of wire, might be a copper wire or aluminium or steel, whatever. What does the resistance of a wire depend on? Well, it depends on the length of the wire. The longer the wire is, the bigger its resistance is. If you imagine, if you double the length of the wire, it's a bit like putting two resistors in series, and its resistance would be double. So the length is proportional to the resistance. The cross-sectional area of the wire, the bigger the cross-sectional area, then the smaller the resistance will be. If you can imagine kind of putting two resistors in parallel, that would be equivalent to doubling the cross-sectional area. So cross-sectional area and resistance are inversely proportional to each other. And then the last thing is the material that the wire is made from. And there is a property of the material which we call its resistivity. Now, some materials are very good conductors because they have lots of mobile charge carriers, such as copper, and they will have a very small resistivity. And then some materials are very good insulators because they don't have very many mobile charge carriers, and they will have very high resistivities, for example, plastic. The equation you need to know, R equals rho L over A, where rho is the resistivity measured in ohm meters. Here's a question for you to have a go at, and the answer is that. To find the resistivity of a metal is an experiment that you need to know. You would build a circuit like this, where basically you can change the length of the wire, you put a voltage across it and you measure the current through it, and you see how the resistance varies with length. You plot a graph of resistance against length, and the gradient of the graph from R equals rho L over A, then the gradient of the graph will be rho over A. A few notes about the experiment. Use a small voltage so the wire doesn't get too hot. We want its resistance at room temperature. It's better to keep the current the same and to change the voltage rather than keeping the voltage the same, because if the current is different for different lengths of wire, then the temperature of the wire will also be different. So it's better to keep the current the same. And lastly, if you do this experiment, measure the diameter of the wire 3 times with a micrometer and take an average. Conductivity. Now, conductance is the opposite of resistance. Conductivity is the opposite of resistivity. Okay, conductivity, we use the symbol sigma, and it's measured in Siemens per meter. And so as R equals rho L over A, then G, which is 1 over R, is sigma A over L, because sigma is 1 over rho. R is 1 over G, rho is 1 over sigma. Here's a question for you to have a go at on conductivity, and I'll show you the answer in 3, 2, 1. Easy peasy.